This is the fourth lecture for chapters 7 through 9, and we'll start off with metapopulations. What a metapopulation is kind of smaller communities of a particular species that does have some carryover between them. So, as a nice example of that would be wolves on Isle Royal. We have a population that has been on Isle Royal for several decades. And as long as the ice was freezing, there was some communication or some refreshing of the gene pool between those locations, the mainland and the island, Isle Royal. And you had, again, genetic information changing back and forth. So the population on the island was considered a metapopulation, separate, but occasionally blending with some other population of its own species back on the mainland. Of course, the problems today is that they don't actually intermix anymore, and you have this isolated group. But as far as the overall population of the wolf, it's okay, because if we lose the population on the island, we still have more wolves on the mainland. So just kind of going through those same message points here. If one group is hit, the rest is not affected. So if the group on the island dies, the rest is unaffected. Okay, world population. Now we're bridging over into chapter 9. The idea that we have a number of humans which is going up and up and up. So 2006, the world population grew by about 0.1 in developed countries. That would be countries like the United States and Western Europe. In developing countries, it grew by 1.5, which has gone down. So here's a couple different scenarios that we could be running into. As far as what most people think the population will be by 2050, it could be anywhere from 7.2, which is really low and probably not likely, because we're above 7 right now. We're probably pretty close to 7.2 right now. So in roughly 35 more years, will we still be at 7.2? There would have to be some changes, definitely some changes. Medium growth would be 8.9 billion, and high growth would be 10.6, which pretty much means that no checks in the system. We're just keep on going. So these are a couple different scenarios that we could have. Looking at some of the different groups in the world as far as what has led us to where we are today. Looking at the yellow is the birth rate and blue is the death rate. So if we just look at the world, for example, for every 21 births, we have 9 deaths, and obviously that's going to lead to growth. And we can look at the comparison between developed and developing countries. You can pause and look at this more on your own. But of course, you can look at some different countries here. What I find interesting is some locations, actually it's not on this map, it's on this one here, is we look at some countries, you can see as an example that the population 2006 and 2025, there's a few countries down here at the bottom, Japan being one, that its population has gone down. Russia, the population will have gone down in that time period. Very, very few countries are in that particular situation. As far as China and India go, I've seen these numbers go back and forth where India will have a larger population by 2025, but in either case they're both still growing a little bit. So fertility rates. A couple things to take a look at here, mostly on the right hand side. Replacement level fertility is the number that a woman has to have in order to just maintain the population that that particular location has. And total fertility rate sounds like they should be similar, but total fertility rate is the number of children that a woman will have during her lifetime of reproductive years. So, looking at some numbers. This number here, we can change this a little bit, and some of the references that I've looked at has been 2.1. So 2.0, 2.1, the reason the replacement level fertility is sometimes 2.1 is because of some deaths that happen in an early age, we put 2.1 in there as a kind of buffer to have replacement for the man and the woman. But seeing how the change in population has moved, in 2006 we have 2.7 children per woman. Again, 2.1 is replacement, so it's going up. But in developed countries, it was 1.6, and now, or excuse me, it is now 1.6, where it used to be 2.5. So it's gone down quite a bit. And in developing countries, it's gone down by an even larger portion. 3.0 is what it is today, or when this was measured, and 6.5 in 1950. So you can see both have gone down dramatically, yet population is still exponential and going up. So, United States, you can see how our population has changed quite a bit. We can see in post-World War II, up until about the mid-60s or so, we can see our population has really taken off. The number of births per woman went up quite a bit, almost 3.5 in the middle 50s, 1950s. But since about the 1970s, you can see, again, replacement rate, they listed at 2.1 for this slide. It's actually dropped below, so we're below replacement level fertility for many, many years. And we'll make note of this here in just a moment. So, what's affecting women and fertility? All of these are listed in there, so you want to hold on to these because I'm sure there's a couple test questions that will have something to do with this. But primarily, and this works around the world, if you want fertility rates to go down, it has everything to do with women, not as a blame factor, but if you educate and give women opportunities, population rates will go down, fertility rates will go down, because women will find something else to do besides having children. So freedom, rights for women is everything. Okay, immigration. Notice that before on the couple slides ago we were mentioning that the population of the United States, fertility rate's gone down, which should indicate that the population of the United States has dropped. But actually, immigration since the 40s primarily, we've loosened immigration rates, which has had a lot of benefits, and some people, depending on your politics, would go one way or the other with that. But in any case, it has allowed our populations to grow. I don't want to say quickly. It still has increased in comparison to what the fertility rates have shown, just for immigration. So more people coming in than leaving. Calculations with migration. So I already got the answers listed down there, but as an example, you have New Zealand, and they have a population of 4.3 million. And they have a total fertility rate of 2.1, remember that number, and they have a migration rate of 2 per 1,000 people. So if we do some math and we want to figure out what will be the population, or the growth in their population per year, what we can do with that is we say, okay, the first thing we know is our total fertility rate is 2.1, which means that our population of 4.3 million isn't changing. But we have a migration of 2 people per 1,000. So if we do a little math and say, okay, well, if 4.3, and I'll say times 10 to the 6th people, times 2 people coming in for every 1,000 people that are already here, we'll end up with about 8,600 people new every year. So if we want to figure out what is that growth rate, we would take that 8,600 people, divide it by the original population, 4.3 times 10 to the 6th, and then multiply times 100% to get a growth rate percentage. And that'll give us 0.2% growth rate. And further with that is we want to figure out what the doubling time will be. We'll take our 70, rule of 70, and divide it by 0.2%. And that'll give us a doubling time of 350 years, which is very, very low. Whoops. Get rid of that. Okay. Next up, age structure is just kind of how the population is divided in a vertical column to kind of get an idea of as far as what the growth rate for that particular population will be. Remember, the age we're going to focus on here is about 15. Sometimes I've seen 18, but we'll go with 15. So here's several examples of some age structures. And notice the countries and what their pyramids look like. Guatemala, Nigeria, Saudi Arabia, they have a very large base of young people. We don't have the ages listed here, but we get an idea this is a young population with a very large number. Slowly expanding, that would be the United States, countries like us. And stable. Interesting, you read about some of these Western Europe countries where their populations are actually decreasing. There's a lot of social implications for that. So countries like Germany, what they have been doing is trying to attract immigration to help support this larger population over here at the top. If they can bring more people in to supply resources for this aging population in retirement. All right, we're at 11 minutes here, so we're going to go ahead and pause and do this last portion for the 5th lecture.